So, let's talk about composite functions today. First, there's a notation that I'd like to go over. This is called F Composite G of X. So that open circle means the word composite. And the notation is F of G of X. If I give you something like F of X is equal to X plus 1, and I ask you to find F of 2, you know that you plug in the 2 to the X, and in this case add the 1, which means F of 2 would be equal to 3. Well, when we talk F composite G, instead of plugging in a number for X, we are plugging in another function for X in this function F. So for example, I have two functions, F of X is equal to X plus 1, and G of X is equal to X squared plus 4. And problem number 1 wants me to find F composite G of X. Well, by notation, that means F of G of X. Order of operations says to take care of parentheses first. Well, brackets are parentheses, and I certainly know what G of X is, so I'm going to write F of X squared plus 4. Now, this tells me to take X squared plus 4 and plug it into the function F. This is going to look like X squared plus 4, because that is now my X plus 1. Why does it look this way? Because F of X was equal to X plus 1. And instead of using the X, I plugged in X squared plus 4 because that was my new X for the function F. And when I simplify this, I end up with X squared plus 4 plus 1 equal to X squared plus 5. Does that make sense? Let's try another one to see how it's working for you. This number 2 says to take G composite F of X. Well, by definition, I take the first function, which in this case is G, of F of X. Whichever function is written first is the one I write on the outside. Whichever is written second is the one that goes on the inside. So, again, parentheses first, G of F of X is X squared, X plus 1. So G of X plus 1. My G function says first write X squared. Well, the new X is X plus 1. And according to the G function, you're supposed to square it, and then you're supposed to add 4 to it. And when I simplify this, I need to figure out what X plus 1 times itself is, and then I get to add the 4 to it. So, we have X squared plus 2X plus 1 plus that 4, which is going to give us X squared plus 2X plus 5. How are we doing? Not too bad? Getting the hang of it? Okay, well, let's take a look at number 3. Number 3 says take F composite F. Plug F into itself, in other words. Okay, notation says take the first function, and inside the bracket goes the second function, which in this case is F of X. And do the brackets first. F of X is X plus 1. And according to this, I'm supposed to take X plus 1 and plug it into the function F. Well, back over here, F of X is X plus 1. So, First thing I'm going to do is write x, which in this case is now x plus 1. And according to the function f, you'll then add 1 to it. Which means after I do my simplifying, I'm going to get x plus 2. How we doing? Getting a little better? Getting a little clearer? All right, let's try this next one then. Definition says g of, this first g of x. The second g is the one that goes inside. Okay, so again, brackets first. So I'm going to do g of x squared plus 4. And now it says to take x squared plus 4 and plug it into the function g. And the first thing I'm supposed to do to the x in the function g is square it. So I'm going to take x squared plus 4, and according to the function g, I am going to square it, and then I get to add 4 to it. Okay, that means I've got to write out this parenthesis twice. And after I do this multiplication, I get to add 4. So I end up with x to the 4th plus 8x squared plus 16 plus 4. And when all is said and done, we get x to the 4th plus 8x squared plus 20. How we doing? Not too bad? All right, well, let's check this out. In these examples, they want us to find the domain of the composite. So we're still finding the composite function, and then we need to find the domain. So let's take a look at number 1 here. According to number 1, I need to find F composite G. Well, the first function is F. That goes on the outside. The second function is G. That goes on the inside. And now I'm going to take F of G, which is x squared. And so remember, according to F, the function F, I'm going to do 3 times my x. Well, in this case, my new x is actually x squared. So I'm going to write 3 times x squared, and then I get to add the 1 to it. And when I simplify it, I simply get 3x squared plus 1. That is F composite G. And they want me to find the domain of this. So, just a brief throwback. When you're finding the domain, you've got 2 red flags that you need to look at for the domain. One red flag is if you have a denominator. The second red flag is if you have an even root. And our most common even root is a square root. Okay, so let's go back to problem number 1. Now that I found the composite, they want me to find the domain of this. So here's the deal. Remember, when you're finding the domain, the initial domain is every real number in the world. Negative infinity to positive infinity. And what you're looking for are any red flags, because if you do have a red flag, then you might be kicking out a number. And if I take a look, this function does not have a denominator and it does not have a square root. Therefore, since there are no red flags, my final domain is the same as the initial domain. Negative infinity to positive infinity. I'm not kicking anybody out. How's that? Does that make sense? Okay, let's go to problem 2 then. Problem 2 is F of G of X by the notation. Well, F of G of X is 2 over X. And according to function f, I am going to take f, which is 3. I'm going to divide it by, first off, x, which in our case is 2 over x, and then I get to subtract 1 from that. So, let's simplify this. I'm going to simplify that denominator. And the denominator needs a common denominator in order for us to work with it. So, I'm going to multiply 1 over 1 by x over x, which then is going to give me 3 over 2 minus x all over x. And that means I'm going to take 3 over 1. Remember, this line dividing, this line between them, means I'm going to divide. So when I do this division problem, it's the same as multiplying by the reciprocal, which will simplify to 3x over 2 minus x. This is my composite function. Now, found the composite, and they would like us to now find the domain of this. Well, according to the domain, according to our red flags over here, I actually have a denominator in this case. And my denominator is 2 minus x. And 2 minus x, my denominator can never be equal to 0, right? Because if it equals to 0, then the whole fraction blows up because it's undefined. So, I've given myself a nice little equation to solve, actually, which means 2 cannot be equal to x, which means x can't be 2. I'm kicking out 2. Out of all the real numbers in the world, I'm going to throw 2 out, because if I use 2, my denominator blows up. Got it. Now, there's one other thing I really need you to notice here. Back in this very first step, where we actually plugged in the 2 over x, I ended up having a denominator within a denominator. And this denominator cannot be equal to what number? You're right, it can't be equal to 0. So not only am I kicking out the 2, but I'm also going to kick out the 0. Because if I plug in 0 right here, right in this very first step in purple, if I plug in the 0, then this 2 over x fraction blows up. And now I'm in trouble. So, my domain can be any number it wants, except for 0 and 2. Those are the only 2 numbers I'm kicking out. Cool? Does that make sense? Okay. Let's look at this third one. Again, by definition, that's f of g of x, which means f of 1 minus 2x. Okay, so I get to plug into the function f this new x. The function f says first write the square root. Secondly, under the square root is going to go x. Well, my new x is 1 minus 2x. And then to that, I get to subtract 2. So, let's look at simplifying this. 1 minus 2x minus 2, which means I get negative 2x minus 1. Now, time to look at the domain. The domain, my initial domain, is every real number. That's my initial domain. My initial domain is from negative infinity to positive infinity. And I'm looking for a red flag. Well, I've got a red flag here. In problem number 2, my red flag was a denominator. In this third problem, my red flag is a square root. And you're like, well, why can you not have, what's the deal about a square root? Why is a square root such a big deal? Well, here's the thing. Can I take the square root of any number I want? Most people would initially say yes. However, when it comes to negative numbers, I can't take the square root of a negative number. If I do, I end up in a whole nother number system, which means square roots are a red flag. So, here's the deal. My number under the square root, and my number is, in this case, is negative 2x minus 1, has to remain positive. It must remain positive. And numbers that are positive are always greater than 0, but they can also be equal to 0. 0 is the joker in the deck. 0 is the neutral card. It's the wild card. So, when I solve this, remember, when you divide by a negative, your inequality sign is going to flip. So in this case, I can use any number that's less than or equal to negative 1/2. My domain is going to be x such that x has to be less than or equal to a negative 1/2. How we doing? So far, so good? Cool. Okay. Now, let's look at these. They ask me 4 questions, A, B, C, and D, and they've given me 2 problems to work on. So, let's look at problem number 1 first. Problem number 1 says they want us to find F composite G of 4. Well, by definition, that's F of G of 4. Well, I work in the parentheses first, and according to the parentheses, the first thing I need to do is find G of 4. Well, let's see. The G of x function is 3x, which means I would have to, in the G function, take 3 times 4, which means G of 4 will equal 12. Now, instead of saying f of g of 4, I'm going to now say f of 12, which means into the function f, I get to plug in 12. So into this square root, I'm going to write 12 plus 1, which gives me the square root of 13. How's that? A little bit nicer because all we're dealing with is numbers, right? All right, let's look at B. B says find G composite F of 2, which means by definition we're going to do G of F of 2. Well, first things first, I have to take care of parentheses first. So in this particular case, the first thing I need to figure out is F of 2. And according to problem number 1, to find f of 2, I've got to take the square root of x plus 1. So f of 2 is going to be equal to the square root of 3. Now, I get to take the square root of 3 and say g of, instead of f of 2, we're going to say square root of 3. And the g function says 3x, which means I get to do 3 times the square root of 3. So how are we doing? Okay, so for problem 1, we're only going to work on A and B. Okay, this was problem 1. For problem 2, we're going to find C and D. So, I need to find F composite F of negative 1. By definition, that's F of negative 1. Okay? All right, first things first, just like we were talking about before, we need to first do the parentheses, which means I need to find f of negative 1. And in this case, my f function is the absolute value of x, which in this case is negative 1, minus 2, which means f of negative 1 is going to be equal to a positive 3. And now I get to find f of, instead of saying f of negative 1, I get to say 3, which means back to f, absolute value of 3 minus 2, which in this case will be 1. Cool? So far so good? Is this making sense? Okay, one more. Let's look at D. D says G composite G of 0. Okay, definition says G of 0. So again, first things first, we need to figure out the parentheses, which is G of 0, which means I am going to take 0 and I'm going to plug it into 3 over x squared plus 2, because this is my G, which is basically just going to give me 3/2, right? Which means I'm figuring out G of 3/2, aren't I? Okay, 3 over 3/2 squared plus 2, 3 over 9/4 plus 2, which gives me, we're going to continue it over here, 3 over, get the common denominator, so 9 plus 8 over 4, which is going to give me 17/4 on the bottom, which is going to give me 12 over 17. Like, wait, how'd you get 12 over 17? Well, I'm going to take 4 over 17 and multiply it to the top and bottom. How's that? We all right? Okay, so let's see. There's a story going on here. Well, it's not really a story as much as you think it is, but it is still a story. So I need you to look at the drawing over on this side, because this drawing is going to help us answer these 4 questions. And if you notice, the graph on the top is the G function. The graph on the bottom is the F function. And I am going to figure out the answer to these 4 problems using the graph. They didn't give me any functions whatsoever. All they gave me were graphs. So, the very first problem that we are going to work on is problem A, which is G composite F of negative 1. G composite F of negative 1. Definition says G of F of negative 1. Well, again, first things first, I need to look inside the parentheses, and the first thing I need to figure out is F of negative 1. Well, let's go over here. F is this one right here. This is the F of x. And negative 1 is my x. And when I look at the f function, the y value I get is 4. So f of negative 1 would be equal to 4. And then I'm going to find g of 4. So g function is this one. The x is 4. and I go up to the G. When I go up to the G, I notice that Y value is 4, which means G composite F of -1 is equal to 4 in this case. Okay with that? Let's try another one. B is asking me to find G composite F of 0. So, when I take a look at my notation, I am going to write G of F of 0. So first things first. First thing I need to find is F of 0. Well, again, that's your F function. And the X value is going to be 0. So I go up to the function F, and I notice that when it plugs in 0, we get 3 as an answer. Which means now we are going to find G of 3, because F of 0 is equal to 3. So my X is 3, and now I go to the G function. This is the G function. And according to the G function, I get 3. So G composite F of 0 would be equal to 3. By the way, it doesn't always work out that way, that I get 4 and 4 like I did on the first one, and 3 and 3. It doesn't always work out that way. It just happens to be working out in this particular case. So don't always assume that that's going to happen. All right, so let's look on part C. Part C wants us to figure out F of G of -1. And by definition, write it by definition, because us visual people need to see this. So, again, first things first, I need to figure out G of -1. So, -1 is over here, and I'm going to go up to the G function. And according to the G function, we end up with 5. Which means now I am going to figure out F of 5. G of -1 is equal to 5. So my new X is 5. And I go to F, and this is the F right here. So according to that, I end up with 0 for the Y value. So, okay, no problem. If that's what it turns out, that's what it turns out to be. So this would just equal 0. Cool. Okay, one more. D wants us to figure out F composite G of 4. So, by definition, this says to write F of G of 4. Again, first things first. First thing we need to figure out is G of 4. So, 4 is my X, and I go to the G function, which is up here. And according to the G function, my Y value is 4. Which means I am now finding F of 4, because G of 4 is now just 4. And when I go to my F, when I plug in my 4 for X, and I go to my F function, it's down here. The Y value is -1. Okay, how's that? Is that making sense? I hope so. What you really need to do is take a very good look at this graph, because this graph is exactly what's going to help you answer these 4 questions. All right. I'm seeing a story. So let's look at this story. There's 2 of them here. Let's look at this first one. So this first one says f of x is equal to 5x squared plus 4, and g of x is equal to 3x plus 2. So they want you to find this, 3x plus a, my fault. So they want you to find a so that the graph of this composition crosses the y-axis at 184. Okay, so f of x is equal to 5x squared plus 4. G of x is equal to 3x plus a. And they want us to find this composition. Great. So why don't we do that first? Why don't we find this composition? Okay, so you know as well as I do the definition. See if you're following along on what I'm writing. Okay, do you agree that's the composition? Good. Now, here's what they said. They said that it wanted to cross the y-axis at 184. So, I know my y is 184. And if this is on the if this is on the y-axis, then what does that tell you about x? That means x must be equal to 0. That means that since it's on the y-axis, this is the y-intercept. And if 184 is the y-intercept, then x doesn't have a choice. X must be equal to 0. Which means our wonderful little equation here is going to look like 5. And in parentheses, we've got 3 times 0 plus a squared plus 4 equaling 184. And by the way, since you're solving for a must be the only variable inside this equation. And it is. So, when I keep simplifying this, I basically have a squared plus 4, because the 3 times 0 drops out, right? It just becomes 0. All we're doing is solving an equation. So see about following along with me. Okay? Got it. Now, one thing I need to make certain that you remember is clearly to get the a squared by itself, you're going to take the square root of both sides, correct? But this square tells you you're going to get how many answers? Yes, I hope you said 2, which means when I take the square root of 36, I don't just get a positive 6, I also get a negative 6. So in this particular case, A has 2 answers, either a positive 6 or a negative 6. Cool? All right, let's look at this other problem over here then. This other problem states the surface area in square meters of a hot air balloon is given by this function. And this function is S of R equals 4 pi r squared, where r is the radius of the balloon in meters. Now, if the radius is increasing with time, times in seconds, according to this formula, well, the formula they've given us is r of t equaling 5 over 6 t to the 4th, and they have a restriction, and the restriction is t greater than or equal to 0. Does that make sense that t has to be greater than 0? Yeah, because t is time, and time is in seconds, and time isn't negative, so that makes sense. So, they want you to find the surface area of the balloon as a function of time. What does that mean? What does that mean? Find the surface area of the balloon as a function of time. That means the only variable that they want to see in your final result is t. They only want to see time. They want the surface area with only t in it. Well, my surface area formula has r in it. They don't want r in it. They want t in it. So notice something. I know S of R is equal to this. I know R of T is equal to this equation. So, if I take the function F and I composite it with the function R, and I need it with respect to time, that means I'm going to take S of R of T. And, again, order of operations, that's 5 over 6 t to the 4th, taking the place of r of t, right? And in my s function, I'm going to write 4 pi, and instead of r, you're going to write 5 over 6 t to the 4th, and according to the equation, you're supposed to square this radius. Does this make sense? Okay, so time to simplify. You're going to get 4 pi. We're going to square what's in the parentheses, which means you get 25 over 36 t to the 8th. I'm going to notice I can cancel the 4 and the 36, which gives me 25 over 9 multiplied by pi multiplied by t to the 8th. This is now S with respect to time. This is now my surface area with respect to time. Does that make sense? So it was a plug-in, wasn't it? It was taking R and plugging it into the S. And when you do that, that is a composition. That is what they were asking you to do. They didn't say composition, but that's what that was. Okay, let's take a look at this next problem. This next problem is talking about the price of a certain product and the quantity sold. The quantity sold is X, and it obeys this demand equation. Price is equal to negative 1/3 quantity sold plus 100, and X has a restriction. They said, suppose that the cost of the producing X units is given by this function. So my function is, my cost is, with respect to X, the square root of X over 100, added 200 to it. They said, assuming that all the items produced are sold, they want you to find the cost as a function of the price. Okay, so if it's as a function of the price, that means the variable I'm supposed to find in the cost function is P. I got X in here. I have X in here. I don't want X. I want the variable P in there. Well, notice something. They tell me P is equal to negative 1/3 X plus 100. I need to make a substitution, don't I? I need to get X out of there, and I need to put P in there. Agreed? Well, I don't know what X equals, but I would if I would rearrange this equation, wouldn't I? So, let's rearrange it. So we need to find X. I minus 100 from both sides. I multiply by negative 3 on both sides. And now I know what X is. So, here's the deal. It is now time to take your C of X and rewrite it, which means you're now going to write the square root of negative 3P plus 300 all over 100, and added onto that fraction is 200. Now your cost function is no longer in x. Your cost function is in terms of p, which is exactly what they wanted. They wanted a function of p, which is like the last problem, right? This problem, the second problem we worked on, they didn't want the radius in there for the surface area. They wanted time in there. So we made a simple substitution, didn't we? We plugged in this R function. So sometimes when we do all these plugging in, it's simply a composite. No, they don't say it's a composite function, but that's exactly what it is. All right, let's look at this next problem. The volume of a right circular cylinder of height h and radius r is given by, so the volume is given by pi r squared times the height. That's how you find the volume of a cylinder. And a cylinder, hey, picture a can of soda. There's your cylinder. If the height is 11 times the radius, express the volume as a function of r. So, in this particular case, all they want is r in there. That's the only variable they want in my function is r. So, notice what they told me though. They gave me a valuable piece of information. They said the height is, remember, is means equals, 11 times the radius. So what do you think you're going to do? You guessed it, plug it in. So my volume, and my volume needs to be with respect to r now, doesn't it? Is going to look like pi r squared, and instead of h, we're going to write 11 times r. So my volume as a function of the radius is 11 pi r to the third. Making sense? Okay, again, even though they didn't say composite, this is a composite function because we took another function and we plugged it in to a function. So even though they're not saying composite, it is a composite function. Okay, last one. Let's take a look at what this one's saying. The manufacturer of a computer is offering 2 discounts on last year's model. The first discount is $400 rebate, and the second discount is a 10% off the regular price. Got it. So you know what? Let's write that down. Before I get to A, B, and C, I need to understand my little blurb. And according to my blurb, the first discount is a $400 rebate, which means the price minus $400, right? Okay. The second discount, they said the second discount is going to be 10% off the regular price. So I'm going to take my regular price and I'm going to subtract from it 10%. Well, that's 10% of the normal price, isn't it? By the way, that's one price. And so if I take a look, that's 1p minus 0.10p, which means I only pay 90% of the original price, don't I, for the second discount? All right. Just making sure we're all agreeing with that. Now, part A. They want you to write a function f that represents the sale price if only the rebate applies. Well, function f, if only the rebate applies, that's our first discount, isn't it? Well, we already did that. Isn't that just p minus 400? Part B. Write a function g that represents the sale price if only the 10% discount is applied. Well, didn't we already do that? That's our second one, isn't it? So we know we're only paying 90% of the original price. Okay, so part C. Part C says find G Composite F and F Composite G. Well, let's find F Composite G first. That means if I take F of G of P, it's going to equal F of 0.90p, which means we have 0.90p minus 400. Does that make sense? Cool. Now look, they said, what does each of these functions represent? Well, we know what 0.90p represents. What does that represent? Yeah, that's us paying 90% of the original price. And then we're minusing the rebate from that. So this is us paying 90% of original price and then subtracting and then minusing from that another $400. That's a pretty good deal, isn't it? Okay, hold on. We got a second part to see. The second part to see was now doing G Composite F of P, which means, by definition, G of F of P, right? I know what F of P was. That was P minus 400. And according to G, we put 90% of P minus 400. So we have 0.90p minus, and then you've got to do 400, right? Times the 0.9. So let's take a look at that. Which is going to be $360. And so what does this mean? This means that we're going to pay 90% of original price. And then we're going to minus from that $360. So, which one is the better deal? Because that was the second one. Which combination of discounts represents a better deal? 90% of the original price minus 400 or 90% of the original price minus 360? Yeah, that's kind of a no-brainer. I'll get an extra 40 bucks if I do F composition G of P. This is my better deal. Because I get an extra 40 bucks off. How you doing? Does that make sense? Feeling a little better about composites? I hope so. Have fun with them, and we'll see you on the flip side.